Thank you very much, Glenn and Alfredo, for inviting me to speak today. It's really my pleasure. And I'm going to speak on behalf of DSA. DSA is the Dynamic Spectrum Alliance, and I am the president of the DSA. And we are going to cover a very large agenda, but I prefer to give you an overview about many subjects and hopefully to receive a lot of questions and have a nice discussion. So if we go to the next slide, Alfredo, please. I just introduced myself. My background is I'm an engineer. I live and work in Colombia. Basically, DSA is present globally, so we have activities and meetings everywhere. And now with the virtual situation with the COVID-19, everything is online. So I invite you to follow us on social media. Next slide, please. And about the DSA, so we are a non-for-profit organization. We represent different companies, civil society, and even universities in our membership. And our purpose is to promote more broadband connectivity and to foster innovation. And we think that for that purpose, spectrum management is very important because there shouldn't be barriers for connectivity. And sometimes the frameworks that we have for spectrum management become barriers. So we basically promote license-exempt access, flexible frameworks for like licensing and different technologies that could increase connectivity. Next slide, please. This is the agenda I have prepared. So we are going to give an overview about different technologies and what we have heard about them so far. And at the end, but please feel free to raise your hand if you have any questions in the meantime. But we are going to refer to 6G, to Wi-Fi 6, Wi-Fi 6E, and Wi-Fi 7. I hope by the end of this conference you will keep in mind what those are. And also spectrum sharing opportunities for 3GPP networks, so mobile networks, and some thinking about the continued need for inclusion. Next slide, please. So about 6G, I wanted to start by this because I think this is like the most recent subject, and this is something that is getting a lot of attraction worldwide. We have seen the evolution of different mobile technologies from 1G to 5G currently, and each of them is improving some aspects in terms of connectivity. So, for example, with 5G, we have lower latency, so that is the time for a message to go and come back. So it means that when we are on a Skype discussion or on a video discussion, we don't see that delay in the communications. We also have machine-to-machine communications. It means that now it's not only about people being connected, but also about device being connected. And we also have ultra-reliable communications. So that is, for example, when you have heard about connected cars. So it means that human life is in danger. I mean, there is no risk for delays in the communication because that has a lot of importance for those applications, and 5G is able also to manage those cases. So what we have heard so far about 6G, that's a process that is going on. It's that we are going to have improvements in many of these aspects, and also that we are going to involve important elements like energy efficiency and artificial intelligence. So it's not only about making networks kind of automated, but even becoming more intelligent. Next slide, please. Intelligent. So in that discussion about 6G, it's important to keep in mind that now in the last, again, it's not only about people, we talk about industry 4.0, so 4.0, and that means that we are getting improvements in terms of productivity, and that is a way to increase economic benefits. So 6G will accelerate adoption of solutions like smart cities, different machine-to-machine communications, energy harvesting, etc. And my point here also, you will see a lot of improvements in virtual augmented reality. Now we speak about holographic haptic communications. It's like you get the feeling of being there because you have that real experience interfaces. So you really feel like you're interacting with others. And there will be also, in terms of spectrum management, a lot of challenges because we are talking about here about terahertz. So it's going to very, very high frequencies for many new applications. And spectrum is a limited resource. So at the end, we will need to have more efficient use of the spectrum. So with different users sharing the same frequency bands. And that's why for us, it's important, because we think that spectrum sharing will be a key component and almost the new norm in 6G. Next slide, please. And also there is a challenge and a lot of reflections on making sure that everyone can be connected, because that is one of the challenges of 5G, that if you don't adopt it in the proper way, you are going to increase the gap, because those in main cities will have excellent connectivity, but if you don't reach, if you don't connect those that are in isolated or rural areas, they will be even more excluded digitally. So that's a challenge. Now let me refer to Wi-Fi. So Wi-Fi is also a group of technologies that has been evolving. So we refer to this as usually as WAS, airland systems. And there are many improvements in terms of generations. Next slide, please. So the sixth generation of Wi-Fi is known as Wi-Fi 6. For those of you that have been on this for a while, you might remember every time we refer to Wi-Fi was IEEE 802.11. So the first generation were 11B, 11G, 11A, and then we were all the time changing the last part of the standard. Now Wi-Fi Alliance has cleverly decided to change that to an easier name. So when we talk about IEEE 80.11.11ax, so it means Wi-Fi 6, and that is the sixth generation. Some of the improvements are that you could have wider channels. So if you compare spectrum with a highway, it means that you could have lanes that are larger. So you can have, instead of just, for example, many years ago, instead of just bicycles or small cars with horses, you can now have big cars, and then you can have trucks. So in this case, and I'm sorry for the analogy for those of you that are experts, but it's a way to explain that with Wi-Fi 6, we can have channels that are larger. So it means that we could have more traffic in the same channel using this improvement of the technology, and then we can have higher throughput and also lower latency. So that is really relevant. Normally for the previous generations, the channel's bandwidth was 20 or 80 megahertz. Now we are able to go up to 160 megahertz. And that is really relevant. Because of that, we could have very good throughputs. So for example, in a smartphone, if you have 80 megahertz, you could have up to 1 gigabits per second. And if you have a channel of 160 megahertz, you could even have 2 gigabits per second on a normal basis. You know, the peak data rates are higher. Next slide, please. If we try to see it from a simple perspective, Wi-Fi has been evolving, and we can have this image from waterfalls. So if we start with 2.4 gigahertz with the first generations of Wi-Fi, that was great, because at the time that was the capacity that was needed. But now users are requesting more and more traffic. So Wi-Fi has been extended first to the 5 gigahertz band. So we have currently 2.4 and 5 gigahertz band for Wi-Fi. And now that's something that is ongoing, is access to the 6 gigahertz band. So that is a new band where we could have more spectrum. So instead of just a highway of, let's say, 5 lanes, we could have really a lot of more lanes. So it would be 1,200 megahertz of spectrum. Next slide, please. On this slide, we can see the different use cases. So here, when we talk about Wi-Fi 6E, let me first clarify that. So it refers to Wi-Fi 6, the sixth generation of Wi-Fi, operating in the 6 gigahertz band. You know, so in that band, you could have very low power devices, low power indoor, and standard power devices. Let's go one by one. So in very low power devices, it means, for example, those devices that you would use for virtual reality applications, entertainment, training, education. So do you imagine some type of glasses, and they will connect wirelessly to a smartphone or to a router. So that connection, it's better if it is unlicensed because it is more affordable for the users and because it's very short range. So you can just use any frequency and then you can have reuse. Those type of applications are portable. You can use them at home, but also you can use them when you are on portable devices when you are outside. The power levels are very, very low, so you don't have a propagation on wide areas. It's just for you and the device. So we are talking about 1 to 3 meters of coverage. Then the second use case is low power indoors. So that is the connectivity when you are at home or when you are at the office. Those are the Wi-Fi networks that we are used to to use. For example, when we are having this type of discussions or homeschooling or working from home. And in this case, it would be improved because of the throughputs that we can get. And in the third case, that is standard power, that is important for outdoor applications. So it is useful, for example, if you have hotspots that for example, in a city, we have many examples of cities that have Wi-Fi on public parks, and then everyone can access to the network. Or in a university campus, you also have Wi-Fi, but it's not only in the classroom, but outside, so students can connect to that network. In some countries, that is also very important for internet service providers. So these are companies that provide Wi-Fi access or basically broadband access to users in hard-to-reach areas. So they use these wireless transmissions and they use Wi-Fi equipment because it is more affordable. And so this type of use case is very important for them. Next slide, please. So if we see all the generations, right now, I mentioned the last generation is Wi-Fi 6. If we use it in the 6 gigahertz band, is Wi-Fi 6E. But the Wi-Fi industry is also working on the next standard that will be Wi-Fi 7. And that is even more challenging because we are going to have channels of 320 megahertz of bandwidth. So instead of 160, 320, and it means a lot of capacity. So we are going to have throughputs that could be up to 30 gigabits per second. I think peak value is about 47. So this is really, really high throughput. And if you see in terms of the modulation, it is much more requiring. It's like we have 4K QAM, and it is expected to be completed by 2024. So that is the new generation. In terms of equipment, there is already a certification process going on for Wi-Fi 6 and Wi-Fi 6E. There are many devices that have been certified. If you go to the website of the US FCC regulator, you will see that there are more than 30 devices. Last time I checked was more than 30 devices for low power indoor applications that were already certified. So this is very recent, but industry is moving quickly, and there are a lot of equipment and devices that have been prepared and developed. Next slide, please. And then we can see here the global momentum. This chart is changing all the time, so we are updating it very frequently. You can see how the 6 gigahertz band is becoming more and more adopted for license-exempt access. I think I just saw your question, Glenn, like, is the spectrum becoming more limited by regulators? I think that the challenge for regulators is making it efficient access. So trying to find out the way of keeping the incumbents, I mean, those that are already using the spectrum, and enabling new use cases. And that is a huge challenge. In this case that I'm referring to, in the case of the 6 gigahertz band, that band is already being used by fixed service, so by microwave links, by fixed satellite service. So there are satellite connections that are important in countries with a hard geography, like it's hard to bring fiber to all the country. And it's also being used by some mobile applications like electronics news gathering. So what regulators that have decided to open the 6 gigahertz band, what they are saying is, we can keep all those services. We don't need to clean the band. But on the top of that, we can have Wi-Fi access or license-exempt access. License-exempt access is good for Wi-Fi, but also for many other technologies. There is even a new radio unlicensed application. So there are some applications of 5G unlicensed that could operate in that band. So this is the momentum. We see in the Americas right now, there are 8 administrations that made a final decision for the entire band, and we are expecting final decisions from Mexico, Colombia, and Argentina. And we have seen also a decision from Europe for license exempt access, not in the entire band, but in 500 megahertz of the band. And we have seen some decisions from, I would say, like leaders on broadband, like Republic of Korea or Saudi Arabia, that have decided to open the entire band. Those countries in blue is because they have current consultations. And for example, we have current consultations in Malaysia right now. We had in New Zealand, and we are seeing more and more countries all the time. So that is the landscape. In terms of Wi-Fi, it's very important to recognize that it is affordable because there are economies of scale. So if you have, for example, in the Americas, with the decisions from those countries, it means 70% of the market in the region. So it means that now there is a regional market, very important, and users can benefit from those devices on affordable prices in the very short term. We are expecting to see the same in other regions. So that's how it's going on. I also see a question about, will low orbit satellites increase launching and utilization? I think from the technology neutral perspective, all the technologies that could increase broadband access are welcome, and especially if that brings competition and low prices. So I would expect to see increases. Wi-Fi is a technology that combines very, very well with other technologies, like for example with satellite. Right now we have fixed satellite services. So for example, I know many projects in Mexico that they call community Wi-Fi. So you have a Wi-Fi, a satellite backhaul link to a community anchor institution, and then you have Wi-Fi as the last mile solution. Wi-Fi is also very useful for mobile networks because and I think many users have seen that. Like when we are not at home, we try to save our data plans. So we say that we don't download videos unless we are connected to a Wi-Fi network. And there are numbers and estimations from Cisco that shows that a very high percentage of the 5G networks traffic and even 4G and 3G networks goes through Wi-Fi networks because of that offload. So decisions for Wi-Fi are also, in that sense, are very neutral because you can use that technology combined to many other technologies. Yeah, Madlut, I will share the links. I think if you search for community Wi-Fi in Mexico, you should find something. I have heard there is a partnership between Viasat and Facebook working on those projects, but I would try to find more on that. Next slide, please. Mulut, also, I see your question about yours trying to see Africa is left out. One of the reasons is because Africa decided to focus right now on a regional recommendation for the lower part of the band. At the ATU level, at the African Telecommunications Union level, they have been working on a recommendation for the countries. And now we are expecting African countries to open consultations about the future of the band. And we expect to see those projects going on. One of the discussions with unlicensed access to the spectrum or license exempt is that, and let's follow the reasoning, it makes sense. So if you are a regulator and you have a frequency band that you can open for broadband access and you can auction that band because you know that industry will be interested on paying for licenses, then you say like, okay, I can auction spectrum, I will receive incomes, I will receive money that I can use for other purposes. I mean, like any public policy purpose. But then I could also decide to make it available under a license exempt access frame, and then I'm not receiving any incomes because of the auction. So that is the thinking for regulators in terms of spectrum management. What DSA stands for is like we say, well, it's important to have a good balance. Because if you have license access, that's going to create certainty for some investment, and that is important. But you also need to have other bands that are license exempt or unlicensed because it creates economic benefit to the society. And so we have been doing some studies on that, assessing the economic value of unlicensed use. in the case of the 6 gigahertz band. And we have seen that there is a huge impact. In the case of Brazil, it's the figure that I'm showing here, we found that the economic impact for the next 10 years, starting this year, because they made the decision, it will be $163 billion. And that is not the money that you receive from an auction, it's the economic impact on the society. So it includes benefit for the GDP, increase of the GDP, what it's called producer surplus, so that is the benefit for Brazilian enterprises, and also consumer surplus to the Brazilian population. So it's very interesting to see and to quantify that impact, because unlicensed access, it's creating opportunities, it's creating a lot of sources of value, and has an impact on the economy of the countries, especially now with the COVID-19 situation and recovering. It's really important to see how it's growing. Oh, Glenn, I saw your comment about 16%. I guess that refers to the previous slide about the adoption of Wi-Fi 6E. Important to mention that it started just last year. So indeed, it's a very high number, because the first decision about the 6 gigahertz band was in April 2020. And in less than 2 years, we have already that huge adoption. So it's growing very quickly, and we expect to have more and more administrations deciding on unlicensed access on the 6 gigahertz band. Okay, next slide, please. So in summary, some of the important aspects of Wi-Fi 6E and unlicensed access to that band is because it's efficient use of the spectrum. You can keep all the incumbents in the band. They can continue growing, but at the same time, there is a possibility of extending that capacity for new services like Wi-Fi. There is a way to attend the growing demand. I didn't go into that, but if you see, all the traffic projections are growing. It could be mobile traffic that offloads traffic to Wi-Fi. It could be also in terms of fixed connectivity, and users are requesting more and more capacity. So if that band is open, it will create the conditions to provide that, to attend that demand. Chipsets and equipment is already available. There are economic benefits, even if there are no licensing fees. It's a way to enable wireless innovation and new use cases for people and companies, like I mentioned, augmented and virtual reality. It's a way to enable additional capacity for public hotspots. It's a long-term vision, because when regulators open the entire band, they are creating a good path for Wi-Fi 7. It's a way also, and this is very important, to create to promote new models of investment, because in this type of approaches, because it is unlicensed, different stakeholders can invest. You are not putting all the pressure of investment for broadband on a few companies, but here you could have a lot of good partnerships, public-private investment. You could have even different sectors of the government, regional governments, national governments investing. So it's really a very interesting opportunity for new frameworks. It's allowing wireless internet service providers to deploy gigabit-class networks. And the benefits are immediate, because the ecosystem is already there. So, it's not like, let's plan for the next 10 years to see what's going to happen. In this case, the ecosystem is ready and devices are ready. So once the regulator decides to open the band, there will be a market, because devices are there. Next slide, please. So now let's focus on another type of dynamic spectrum access and spectrum sharing that is very interesting. It's how to make most profit to get a wider ecosystem in terms of 3GPP networks. So next slide, please. I don't understand very well your question, Glenn, about ham radio getting impacted by more efficiency. Maybe if you can provide more details. In the meantime, I will continue speaking here about those new frameworks for dynamic spectrum access. So in some cases, the traditional model is like, we find a frequency band that is suitable for broadband access, And in the case of mobile, we go through a process of identification of the band for IMT. Then we go through the assignment process. We assign the frequency band. But before assigning it, in most of the cases, we need to clean the band. I mean, until now, whenever you have a mobile assignment, you need to clean the band. And that is complicated because you need to migrate users, and it takes time, and it's very costly process. So it's not, I mean, that's the way we are doing it, but it doesn't have to be always like that. And a good example of that is the case of CBRS, Citizens Broadband Radio Service in the United States. So it started because in the 3550 to 3700 megahertz band, so 3.5 gigahertz mid-band, important for 5G applications. In that band in the US, there are incumbents that are from the DoD, so Department of Defense, and it was not possible to just say to those users, well, go somewhere else. So the FCC and many other authorities in the US worked together to create this framework. And this is based on spectrum sharing. So you have different type of users with different priority levels, and all of them can coexist and operate in the same frequency band. The management of those users is done through a spectrum access system known as SAS. And that is securing the resources that all the users need. And it is always available for military applications and also for public sector incumbents. So they keep the spectrum. They continue operating in the band, but at the same time, it's possible to have new users. So that's why we talk about efficient use of the spectrum and wider ecosystem. Next slide, please. So here you can see simplified version of how it works. So tier 1 are users that have the priority always. So in this case, I was mentioning military applications. Then you have a second tier of users that have priority access. So they get a license. They are part of an auction. They pay for the spectrum. They get a permission to use the spectrum for a certain period of time in certain localities with certain conditions. And then there is a third type of users that is known as general authorized access. So those in the third level, they can access the spectrum if they don't create any interference to users on tier 1 and tier 2. And it's very interesting the way it works. Let's see the next slide, please. It has created a very large ecosystem. It's a success story because you have seen, well, incumbents keep operating. So for them, they are still in the frequency band, they can grow, they can continue there. For priority access, it was very interesting because the FCC had the auction last year. They opened 70 megahertz of spectrum. There was a lot of interest, and it was also an auction where many entities received access to the spectrum. So it was really broad in terms of participants. And you can see here some examples. So there were private entities and companies that decided to get their own spectrum so they can deploy their own networks, their mobile networks. They don't need to go through an MNO, or sometimes they can partner with the MNO, but they have the rights to use the spectrum. It was also important for cable and companies that say like, okay, we have cable, but we don't have access to the spectrum. So with this framework, they can have a license also for particular access to the spectrum. And there are new business models like neutral host. So those are companies that are deploying networks, and then they open that for different users, and they have some roaming agreements, and they create infrastructure for airports, shopping malls, arenas, etc. And it's also good for WISP. Remember, I was speaking about the wireless internet service providers. Traditionally, they were only able to use unlicensed spectrum. But now, with this type of frameworks, they can also have access to the spectrum and provide broadband solutions. So generally speaking, and traditional wireless too, I forgot to mention, they are very important ones because those are the companies that have been traditionally on the MNO providing mobile networks, and they also increase their capacity, and they could make some carrier aggregations and they take benefit of their other frequency bands, combining them with CBRS. Next slide, please. So here are some numbers and some of the arguments of why we say it's a very successful story. The full commercial deployments started last year in January 27. And in just, I would say, 1 year and a few months, these are, let's say, 1 year and 8 months, there are more than 150,000, that number increased, 150,000 cellular base stations deployed. That's huge. You know, that then getting that number of base stations in 1 year and a half, it's amazing. And that is because you don't have only one or two companies investing. They are there. I mean, big MNOs are part of this success, but you also have many others that are investing. And so deployments are amazing. There are many use cases: mobile, broadband, fixed wireless access, private use cases. The auction was successful. It concluded in August last year. And as I was mentioning, there were 228 winners. So that proves how large the ecosystem can be. It's also very interesting for competition because SaaS administrators, there could be any companies, I mean, companies that are specialized on that. And right now it's open. So there are 9 authorized SaaS administrators. There are more than 130 models of devices of CSBSD, so that's like the base stations, and more than 220 authorized client devices. So there is an ecosystem in terms of equipment and devices. And also it creates new jobs because then you have certified professional installers for CBRS. So that is really impressive if you compare it from the wider ecosystem perspective. Next slide, please. And that is not taking into account the users that don't require a license, you know, because I mentioned 228 winners. That is for the tier 2, but you have for the general authorized access, you don't need to get a license. You can just, if you register to the SaaS and you notice that you can use the spectrum in that region, you just follow the rules and you're able to deploy your own network. Let's see very quickly the questions. How does the spectrum auctions impact the implementation? That's very important because that is the trade-off. MNOs want certainty about the investment, but at the same time, if the auctions are too expensive and they have to pay a lot of a very high amount of money for just accessing the spectrum, if regulators don't find the good trade-off, then it could compromise the deployments of the networks because you pay too much for spectrum and then it's hard to invest on the networks. It's a for-profit operation, but still you need to find the right trade-off. And that is the advantage of license-exempt frameworks when they are very well designed, that you could incentivize more deployments, and at the same time, you can create good conditions for competition and better services for final users. So with that in mind, after the description of CBRS, we could think about a model that is more general and that we call SSM, so spectrum sharing model, where you could have different tiers of users, different types of users, and then you could try to manage that in order to accomplish some policy goals like competition, investment, spectrum for verticals and private networks, but also digital inclusion. Because you could perfectly imagine that in a place that doesn't have a good broadband connectivity, someone can say, okay, I can create a GAA, I could create my own network and have my community network with access to the broadband access, and I don't have to pay for the spectrum. Next slide, please. So in that context, CBRS is one example of SSM, because in that case of CBRS, tier 1 users were the military radars, fixed wireless access, fixed satellite service. Tier 2 were the users that got a license, and tier 3 are the general authorized access. But it could be, for example, in a country that doesn't have the same conditions of the US, because most of the countries don't have military operations in the 3.5 gigahertz band. But they could implement something like that. They could have an auction, give the spectrum to MNOs, and at the same time create the use it or share it conditions so others can use the spectrum whenever or wherever the incumbents are not deploying. So it could create opportunities for sharing, and that would be useful for smaller MNOs, for wireless internet service providers or for verticals and neutral hosts. So in that case, that is the way we see it for other countries and administrations. Next slide, please. So now let's see opportunities for spectrum sharing. So in general, spectrum is physically limited and valuable resource. The technical coexistence is possible in many cases. Like from the technical perspective, you can manage it. It's just that the licensing regimes are always, I would say, sometimes they are the ones that are blocking those new models. And it takes time for regulators to update them. So I think it's part of our advocacy to explain how these tools work and all the opportunities for using them, because at the end, there are much more benefits if decisions are made. Clearance processes are complicated, expensive, and they might take long time. Spectrum sharing is an alternative to release more spectrum for broadband without any clearance process, without migration, and also in a faster way, because if you don't need to clean the band, you can just give access very quickly, protecting the incumbents. It's possible to use tools as databases, as I was explaining with the SAS administrators. Spectrum sharing frameworks should provide opportunities for large and small entities. That's something very important. We need to understand that the communications market is not just about a few companies. If we create the conditions for a larger ecosystem, it will be more competitive, and also we'll have more investment from different sources. It has benefits for industries and innovative business case, and increases competition and better broadband coverage. Next slide, please. And the final thoughts about the continued need for inclusion. So here we have referred to 6G, to Wi-Fi 7, to CBRS and very innovative models, but we still have a huge problem in terms of access to the internet, and that should be addressed. So next slide, please. From the DSA perspective, one of the technologies that can help to this challenge, it's TV white spaces. In general, we think that it's important to have a combination of technologies, like I was referring in my question about low orbit satellite. So we think it's good. It's good if you could have different solutions, but sometimes it's not the technical challenge, it's the economic challenge. So how to reach some areas that don't have a very high ARPU, so people just, they're not able to pay for a very expensive plan. And how to get there. Deploying fiber for many regions is just not feasible at this time in terms of economic the cost of that. And in that type of solutions, for example, TV white spaces is very good because it's using low frequencies. So low frequencies have better propagation than very high frequencies. And then you can use, it's a type of point to multi-point technology. And then you create broadband connections for those hard to reach areas. So this is a map of some of the most recent decisions. Brazil, and we are very excited about that. Just last week, Brazil decided to accept and approve regulations for TV white spaces. So now Brazil is also blue in that diagram. Next slide, please. And there are opportunities for spectrum sharing because TV white spaces can help address the connectivity gap. And in that case, it's also spectrum sharing because we have broadcast that is allocated to those frequency bands. But in many cases, most of the time, you don't have all the channels being used by TV. So TV white spaces is using those channels that no one is using. It's not taking spectrum away from anyone. It's like those are channels that are idle. So you can use those channels to provide internet access. And that is why it is a very efficient use of the spectrum. Next slide, please. And one of the final thoughts is you need to create conditions for flexible frameworks because you have more opportunities for strategic collaborations. So, for example, in the case of the 6 gigahertz band I was explaining before, you have incumbents. But even if those incumbents continue there, you make a most efficient use of the spectrum, enabling access for Wi-Fi. And in those cases, you're recognizing also the importance of different types of access, fixed, and how it combines with mobile networks, because it combines very well, and as I explained, with satellite and other networks. And if you bring together industries, you are not just choosing one or the other, you are giving the right conditions for all of them to grow and to compete. So I think also answering one of the questions I had at the beginning is like that's the trade-off for regulators, trying to create conditions for all the technologies to grow, making sure that they can compete with the right conditions. Because if your decisions are just focused on one industry, then I think somehow that's what has been happening in the last years, that if we keep doing the same, we have seen that there is still a huge gap in terms of connectivity. So my message also, it's like, we can think out of the box and just not keep doing the same thing. We can keep doing the same thing, but in addition, implement new frameworks and create new opportunities for new solutions in terms of inclusion. Next slide, please. And I think that's my final slide. So that's why we say at the DSA, we say a new spectrum mindset, because we can keep doing the same thing as we have been doing for a while, like saying, okay, let's keep it exclusive access, license access, pay for that. And I mean, there's nothing against that, but that hasn't been enough. So our message is, let's try to have a new spectrum mindset and try to find those cases, those applications, those technologies, and see how we can enable opportunities for them and for users and for a wider ecosystem to increase connectivity and increase digital inclusion. So that's my presentation. I'm sorry I went very fast, but I wanted to go through it completely so we can have some time for questions. Thank you.
Thank you, Martha. This is Alfredo. I do have a question for you. You have been talking a lot about the technical aspect of moving through Wi-Fi 6, 6E, and the future Wi-Fi 7. And you also have mentioned how can we deal with inclusion to get those isolated communities access. Now, I was wondering, are you doing something to educate the end user to understand the advantages of having these new Wi-Fi spectrums available and how to use them in their day-to-day life?
There are two parts in terms of the spectrum. That is a very good question, Alfredo. One is that we have been doing studies about the economic impact, and I invite you to see them at the DSA website. So we have done studies for Mexico, Colombia, Brazil, Peru, and now we are finalizing studies for Indonesia, Kenya, South Africa, and Nigeria. And what we have found is that in those countries, most of them, WISPs are very important. They already use Wi-Fi to provide connectivity for final users. In Brazil, official numbers from Anatel say that 30% of the fixed access is provided by those wireless internet service providers. And they basically, what they are doing is that they are getting the equipment that is available for Wi-Fi at 5 gigahertz network, and they deploy their networks. And it's more affordable, and that's how they can offer broadband to many users that otherwise cannot afford a fixed connection. There are some issues there, because sometimes they are small companies. They are not really very well organized. In some countries better than others, but in many they are not very well organized, and they are seen as chaotic by the regulator because they are creating networks here and there. And because it's license exempt access, it's like you just need to respect the rules and you get the equipment and you can install that. So from DSA, we are working on the two sides. First, making sure that regulators recognize that, because they are key stakeholders for the connectivity, and they should get what they need in order to provide that service to their customers. And on the other side, we are also creating capacity building for those stakeholders, like letting them know license exempt access doesn't mean anarchy. It doesn't mean that they can use it however they want. They have to follow the rules, they have to respect the restrictions, and in many cases, even if they don't need a permission for the spectrum, they need to register with the regulator to provide internet access. and they have to pay some fees for that internet service providers solution. So we are working on the two sides of it, and we think that when you have that conversation, it becomes really positive because they are doing something that for other stakeholders they just don't find a business case in many hard to reach areas. But these small companies, most of them are local. Most of them can rely on affordable equipment because of economies of scale. So they find a business case where they can provide access, and that is sustainable in the long term. So I hope I answered your question, but yeah, we are working on that capacity building challenge.
Glenn, go ahead.
Yeah, a couple of things. Let me just ask you directly, because I saw Charles. He had some issues with the audio earlier on, but he did bring up the issue of it's the conspiracy theory of COVID-19 and Spectrum. So you know that in the UK, especially, many of the towers have been sabotaged, and can you address that issue?
Yes. Are you referring to some of the myths about 5G increasing COVID and all that?
Yes.
Yes. Well, that's yeah. That's. I think there are always people that are, I don't know, that are taking benefit of general not expertise on some such subjects. And it was I saw many news about saying that 5G antennas could create increased COVID risk and all that. Even at the Americas level, we had a press release from CITEL, that is our regional organization for the Americas, and they were saying that there were no studies showing any influence on that type of equipment and any COVID-19 situation. And I think now it's clear. Now we have understand more. We have more information about the virus. So yeah, I mean, that's completely no sense and just trying to create panic. That's my impression.
Okay. Let me turn back to a question that was from Malud earlier on. He particularly wanted details about community Wi-Fi in Mexico, and if you have any links, he'd appreciate it as well. Thank you.
Yeah, I'm just sharing it here. I just wrote it. Can I write here? I think I cannot. Oh yeah, I can. So I just found this is in Spanish. And I know this is a project from Viasat, but ESOA has been also speaking. It's not only about one company. There are many satellite companies that are providing that backhaul access, especially for hard to reach areas. And then they provide the backhaul, and then you create a Wi-Fi link for a community. So, for example, in Mexico, what I have heard is that there are large areas, and then you go to a place where you can shop all your groceries and market. And then you go there, and then you have Wi-Fi access for the community. And you can buy 1 hour of access by a very affordable price. And because it's massive, everyone can do it. And that's how it's sustainable. And it's working very well. And I think it makes sense because we need to find those innovative solutions for users that don't have access to internet.
Okay, Malud, are you happy with that? I'm just looking at, he's typing something else. So he'll probably be, thanks. He's got that. So I did a project a couple of years ago working with ham radio to do a point-to-point system as a small mesh network. Unfortunately, the technologies, is not it doesn't have the capability to burn through trees. So when I had a 9-point, it was a mesh network to a tower, which 9 kilometers away. But with the point, we hit a set of trees, so we were not able to set up the mesh network. Does you were talking about TV white space? Does TV white space have a better capability than your typical small mesh network systems to be able to overcome those issues, such as buildings or trees that interfere with the network?
Yeah. And before answering this question, Glenn, Viasat is not one of our members. So I'm just letting you know about it. It's not a promotion of Viasat, is because I know I have heard about them in many events. So that's why I'm sharing that information. the question about TV white spaces, yes, it is. I mean, the propagation conditions, we had, at the time when I was working with the Colombian government, we had many trials to see how it works. It really depends on the landscape. For example, we had a pilot in a region in the north of the country that is on the sea, and there the landscape is like that. And then you had the propagation that was amazing because it was near to the sea, just a very few trees, and that was amazing. But then we had some trials on the mountains region, and depending on the mountains, there are two types of mountains. So in one where you had normal trees, but a lot of really changes in the geography, if you could fix the link on the right direction, it was working great. We also had some cases where you had mountains and very, very high trees. In those cases, it's more complicated, but it could still work. You need to make the propagation design and you know the path analysis from the technical perspective to make sure it works. But what is for sure is that it will work better than other technologies that are using higher frequencies, because you just don't get a line of sight. So in any case, you're not going to get any line of sight links. And then in those cases is when TV white spaces is very important, because for those configurations, it could work. It doesn't work all the time, but it could work. And then you could have very good propagation for large distances. So my advice would be for anyone who is really interested on that, you should have the profile of the terrain, and you should run some simulations, because it's not about saying, yeah, it will work, it will cover 20, 30 kilometers. Probably not. It depends on the geography and the conditions.
Okay, great, thank you. I'm just looking for anyone else that has any questions. If not, I'm going to turn back to Alfredo.
Yes, Martha. I do have another question. In terms of innovation, I know you spoke about the future of Wi-Fi 6 and 6E and the developments that some organizations, companies will be investing their time in. Now, I'm wondering how far in the future, or how close in the future, do you see some of these new innovations in place and available so that people can adopt them?
Alfred, do you mean for Wi-Fi?
Yes. Yes, for Wi-Fi 6 and so forth.
It's now. I mean, we had the decision. So I refer to the 3 use cases because the 3 of them are different. So most of the regulations we have right now in many countries are for low power indoor applications. And then it's a very easy coexistence, from the technical perspective, because devices are indoors. So they don't create any harmful interference for fixed satellite service or fixed links. They are indoors, easy. Then you have VLP, very low power applications. Because the power levels are so low, you can also have a very good coexistence. Most of the decisions so far are creating those use cases. The third case, that is standard power, that is the one that needs to have an external mechanisms to coordinate the access. In the US, they call it AFC, Automated Frequency Coordination Systems. And that has been approved by the FCC. Last week, there are many new announcements. Last week, we also had the announcement of a public notice where the FCC is defining the conditions on how AFC providers can get certified and can start to operate. So this is creating immediately those conditions. We also have Canada that approves standard power applications, and we have seen a lot of interest from other countries that say, okay, we don't approve standard power applications right now, but we are very interested in having them in the short or medium future. So I would say about Wi-Fi innovations, everything related to VLP, LPI is already there. Standard power is in the process. It will be related to AFC deployments, and we also expect to see that very soon, because decisions are already there, like in the case of US and Canada, and the conditions for certifying AFC is on the way. So yeah, I think very, very soon we will see all that.
Okay, thank you. Glenn?
I think that's time is up. This has gone great. Thank you again, Martha, and it's always a pleasure to see you. and we appreciate your time and energy. And we're going to be recording and sharing this slideshow for the other students who could not make the time zone. So we do appreciate your time today. And I saw that at the beginning of the slide you had your email address. Are you okay having people contact you directly? Okay.
Absolutely. It would be my pleasure. And I also share my social media information. So I also reply Twitter message on private messages by email. Happy to keep in contact with students.
Well, it's been a great pleasure for all of us today. And again, thank you for joining us today. And thanks for everybody who made it to our call today. And as always, we'll have this recording configured and in our collection. So again, Alfredo, who's our speaker next month? Sorry, next week. Oh my! I think it's John Crane. He on security from senior staff person from ICANN, I think. Yeah.
Yes.
It came to me. I drew a blank there for a second. Okay. Thank you again, Martha. All the best.
Okay. Thank you, guys, and have a great day.
Thank you. Bye, everybody.